Welcome you all for the SWAM course Animal Waste Management. Today module is Animal Waste and Environment, Week 4, Lecture number 1, and the today topic of discussion is methane emission from the animal waste. Myself, Dr. Anuradha Kumari, Assistant Professor in the Department of Livestock Production and Management, Faculty of Veterinary and Animal Sciences, Rajiv Gandhi South Campus, Barkacha. Today we will discuss the methane emission from the animal waste via under the following subheadings. A brief introduction or summary of different greenhouse gases. What are the different ways through which animal, livestock or livestock waste contributing the release of different greenhouse gases, and mainly we are concerned with the methane emission. What are the different ways through which methane are emitted through the livestock species, and what are the different mitigation strategy should be applied to reduce these emissions. As the demand of animal product is increases day by day because of increase the per capita income of the people, rapid urbanization and changing the lifestyle of the people. However, the factors such as climate change, competition of the land between the animals and human, and food security have negatively impacted the animal production. One of the biggest way the livestock farming contribute to the climate change is the release of the greenhouse gases. These greenhouse gases trap the heat that is radiated from the environment and lead to the increase in the global temperature. India is the third largest producer of greenhouse gas globally after the USA and the China, and India stands second position in relation to the methane emission through the various anthropogenic sources and natural resources. Today we will discuss the three important greenhouse gases, that is carbon dioxide, methane and nitrogen oxide. Most important is the carbon dioxide. Carbon dioxide is the main greenhouse gases and it comprises the 80% of all the greenhouse gases. Carbon dioxide exists in the nature naturally and circulate between the earth and environment through carbon cycle. The half-life time of carbon dioxide is in the range of 100 to 300 years. Next important greenhouse gas is the methane. Methane accounts about 11% of the global greenhouse gases. Unlike the carbon dioxide, its half lifetime is very short, that is only 12 years. However, it is much more effective in trapping the heat in comparison to the carbon dioxide over a period of 100 years. 1 pound of methane is 23 times more potent for the causing the global warming compared to the 1 pound of carbon dioxide. Next greenhouse gas is the nitrogen oxide. It will make only the 6% of greenhouse gas globally. Nitrogen oxide also exists naturally and transfer between the earth and environment through the nitrogen cycle. It remains in the atmosphere for 121 years after its release into the environment, and its global warming potential is 296 296 times greater compared to the carbon dioxide. How the different livestock waste and livestock contribute to the release of different greenhouse gases? The concentration of these greenhouse gases, mainly the methane, in the atmosphere increased by 45% since 1850. What are the different contributing factors that lead to increase in these greenhouse gases? Most important is the increased livestock production that contributes significantly for the increase of these greenhouse gases via the enteric fermentation or through the livestock waste. If we see for the Indian condition only, the enteric fermentation via the animal Indian livestock contribute 15% of the global emission. According to one record that the belching of the different ruminant species in India emit on average 9 to 14 million ton of methane gas annually out of the total 19 million ton excreted globally. That will come around almost 15% as we have discussed. What are the different ways through which animal farming or livestock contribute to the release of different greenhouse gases and mainly the methane? Most important, for the rearing of animal we require the feed. For growing the feed and fodder, there is change in the pattern of use of land. For growing the fodder, different type of fertilizer are used. For growing the fodder, same different agriculture processes, different the feed processing like the pelleting is done, and the transfer of feed from the site of production to the site of fertilizer, for that different type of transportation activities done. All these process all together help in the production of feed that is required for rearing of the livestock. So this is the major component through which animal production lead to release of the different greenhouse gases. All these rates point are showing the direct emission, direct contribution of livestock for the release of different greenhouse gases. You can see that the enteric fermentation is the second largest source of methane from the livestock sources. Basically, the two way through which livestock contribute to the release of the greenhouse gases methane, that is, first one is through the enteric fermentation. In enteric fermentation, along with methane, different gases are produced. However, methane contribute around 30 to 40% of all compared to all the gases that are enteric fermentation and excreted through the process of belching via the mouth and the nasal cavity. Almost 90% of the gases produced during enteric fermentation is removed via the mouth and only 5% is removed by the anal opening. Second way through which livestock waste or livestock contribute to the release of methane is through the manure management. In manure, methanogenic bacteria under the anaerobic condition lead to the production of different greenhouse gases, mainly the methane. In today's lecture, we will mainly concentrating to the release of emission of methane through the enteric fermentation. So first we will start discussing what is the enteric fermentation. Enteric fermentation is a natural digestive process of ruminant, whereas different microbial population like the bacteria, protozoa and fungi break down the structural carbohydrate like the cellulose and hemicellulose of the plant into the different volatile fatty acid, that is acetate, butyrate and propionate. By the human wall, all these volatile fatty acid via the circulatory system reaches to the liver, which is the most important, a major part for energy in need of the animal. During this fermentation, the methane mainly produces in the rumen by the RK, that is methanogens, that produces methane as a byproduct of the fermentation. The amount of methane produced during this enteric fermentation is mainly by the acetate. As we have discussed, acetate is the primary volatile fatty acid produced during the fermentation, mainly the fibrous fluid. When any type of the condition and fermentation or when animal conditioning more fibrous food, more acetate is produced and lead to the more methane production. Along with acetate, two other volatile fatty acids also produced during the enteric fermentation is the propionate and butyrate. However, production of these two volatile fatty is more energy efficient method because it reduces the methane production because of the alternative pathway is required is used during their formation. As we have discussed, during the enteric fermentation, along with the methane, different gases like the carbon dioxide and hydrogen sulfide are also produced. However, methane emission in the rumen is important and evolutionary adaptation. If methane is not produced, means there is no capturing of hydrogen that is produced during the bacterial digestion of the complex plant carbohydrate. So there is a not proper fermentation of carbohydrate and not proper degradation of the fiber consumed by the plant and no release of energy that are finally used by the animal. The amount of methane produced during the fermentation, that is mainly the enteric fermentation by the different microbial population, it depends upon by the primarily with the number of animal, type of digestive system animal have. Means Normally there are two type of digestive system, monogastric type and the polygastric type. The polygastric animal are mainly responsible for through their enteric fermentation for the release of methane gas, and the amount of feed consumed also determine the amount of the CH methane produced. What are the different pathway or the subtract used by the methanogen for production of methane? There are the basically three subtract that is used for the methanogen. That is, first one is the methylotropic methanogen that uses methyl group as a substrate for the production of methane. Second category of methanogen which uses hydrogen and carbon dioxide are hydrogenotropic methanogen, which uses hydrogen and carbon dioxide as a substrate for the production of the methane. This is the most common method, and these both are the most common substrate is used by methanogen for production of methane. And the third is the acetate, and that type of methanogen are the acetoclastic type methanogens. Methane enteric fermentation leads to the release of methane, that is an important greenhouse gas as we have discussed, and it's lead to global warming. Enteric fermentation or release of methane is not only affect the environment, it has a negative or detrimental effect on the animal system itself. During the process of methane generation, on an average 2 to 12% of gross energy is used for the production. Otherwise, if this amount of energy is not used for the methane product, that will be utilized for the different purposes like the growth, reproduction and meat production. So, because of the production of methane, there is loss in the energy. Again, because of release of methane production during the enteric fermentation, there is an increase in the competition between the microbes that help in the synthesis of microbial protein and for the nutrient and the carbohydrate. Because methanogen compete these protein producing microbes, so finally there is a less production of the microbial protein as a release of formation of methane during the enteric fermentation. What are the different factors that determine the amount of methane produces during the enteric fermentation? First and most important is the diet composition, the type and quality of diet. If animal, mainly the ruminant animal, consuming the more fibrous and more feed which is rich in the structural carbohydrate like the cellulose and hemicellulose, that lead to the more methane production. Any type of the feed which is high in fiber content require more fermentation time and lead to the production of more methane. Again, in the diet composition, the digestibility of feed, more digestibility the feed, less is the production of methane. High quality feed having high starch content, easily fermented, less fermentation time, so reduce the production of methane. Next factor that affect the methane release is the animal species. As we have discussed, monogastric are less important emitter of methane because compared to the polygastric animal because of their enteric fermentation mechanism in their digestive system. Age of and size of animal. As age of animal increases, the amount of feed requirement is increased, so more and more methane is produced as a result of the digestion process. Type of microbial population. As we have discussed, there is a different type of microbial population like bacteria, fungi and protozoa present in the rumen that help in the digestion of the structural carbohydrate and release of different volatile facets that is act as a source of energy. So the types of microbe present in the rumen have a significant effect on the amount of the methane production. And second is the animal activity and health. Animal under the stress and the disease condition, and if animal are under the discomfort condition, so the animal feeding efficiency is reduced, so more and more time is required for the proper digestion and fermentation of the feed, and finally this leads to increase the methane production. Here you can see the contribution of different livestock species like the sheep, goat, cattle, buffalo in total amount of methane production under the Indian context. You can see that the bovine species, that is the buffalo and cattle are the major contributor, and approx 97% contribution of methane is from these bovine species only. If you see within the bovine species, the productive about the 60% of methane from the buffalo population is coming from the dairy type of buffalo. However, in the case of the cattle, about the 75% of the methane emission occur from the non-dairy type of cattle. Among the non-bovine species, goat is the main predominant contributor for the methane emission, followed by sheep and the pig. So, what are the different mitigation strategies should be followed during the animal management system to reduce the emission of the methane gases? As we have discussed, ruminant is the most leading contributing factor for the release of the methane through the anthropogenic sources. So, any strategy that reduces the emission of the methane will mainly work for improving the fermentation efficiency and finally that improve the animal productivity. The different area mitigation strategy that are broadly classified into improve the animal breeding and the management, different type of feeding alteration, forage quality and different of human manipulation. These are the mainly broad area in which we have to work to reduce the amount of methane emission through the different livestock species. As far the animal breeding and management is considered, we should do the selective breeding for the animal which naturally produces less methane. Some animal naturally produces lower methane due to difference in their digestive physiology and the type of microbial population that they have in their digestive system. As far the animal management is concerned, by improving the animal grazing system, by applying the rotational grazing, that will help in maintaining the health of the animal by providing the quality type of the pasture to the animal and finally help in the reduce in emission of the methane. Along with that, during maintaining the health of animal and maintaining the animal in stress-free condition lead to overall improvement of animal welfare, indirectly help in reduction in the methane emission. Different type of feed additive have been tried to reduce methane emission mainly through the enteric fermentation. Most important is the electron acceptor. As we have seen that the methane in the rumen is mainly produced by the combination of the carbon dioxide with the hydrogen. If we develop any alternative strategy who will accept the hydrogen that will not available for a methanogen for the production of methane, through that mechanism we can prevent the emission of methane through the enteric fermentation. One such strategy to reduce methane production is to provide the alternative electron receptor that compete the methanogens for the hydrogen by reducing the availability of hydrogen for the methanogen by using the alternative electron acceptor. There is a shifting of fermentation pathway and result in the production of more efficient volatile acid, and that is the propionate and butyrate, and finally reduce in the production of the methane. Example of such type of electron acceptor are the nitrate, fumarate and sulfate. When nitrate are used, it is converted into nitrite and by accepting the hydrogen in the rumen and finally reduce in the production of methane. Other feeding mechanism, feeding additive that can be used to prevent or reduce the emission of methane is the use of ionophoric antibiotics. Ionophore are the chemical compound that mainly work by modifying the fermentative mechanism in the rumen. They specifically target a certain group of bacteria. May they affect their ion transport across the microbial membrane. By changing the type of the microbial community, ionophores help to reduce the methane production help to reduce the hydrogen production, and finally help in the production of the methane. Example of such type ionophore are monensin and lactaloside. Monensin is most widely used ionophore in the ruminant nutrition. It selectively inhibits the certain species of bacteria in the rumen, so modify the rumen fermentation process, and that will result in the reduction in the methane production. Certain chemical inhibitor directly act on the enzyme that is used by the methanogen for the production of the methane. One such type of chemical inhibitor is the 3-nitrooxypropanol. It works by interfering the enzyme that is involved in the final step of methane formation, particularly the methyl coenzyme M reductase enzyme that methanogens uses to generate the methane to produce the methyl group for the production of methane. Other feed additive like the direct feed microbes or probiotics can be used to reduce the methane production. One such example of direct feed microbes is the lactic acid bacteria. When this lactic acid bacteria are fed, this result is into production of more propionate by reduce the hydrogen availability for the methanogen. Means this direct feed microbes improve the human fermentation pattern. Along with the different feeding system, different vaccines are also tried to work particularly on the particular group of bacteria that are involved in the methane production. Though this work is very at initial stage, but there is so much scope. By use of this vaccine also we can reduce the emission of the methane via enteric fermentation. In the plant, other mechanism that can be used to prevent the release of methane via enteric fermentation. Some type of secondary metabolite present in the leaves of the plant. Such type of secondary metabolites are tannin and saponin. This tannin is mainly a phenolic compound found in the various plant species that reduce the methane production by inhibiting the methanogenic activity. These tannin are present in the leucaena and tamarix leaves that can be used to reduce the methane emission. Saponin is also a type of secondary plant metabolite that help in the reduction of methane emission through the enteric fermentation. By use of this secondary plant metabolite result into the reduction of methane emission by 10 to 15%. By improving the forage quality, we can also control the methane emission. Any factor which improve the digestibility of fodder, any factor if we improve the protein content, and if we alter the microbial population, that will result into improve in the fodder digestibility, altogether help in reduction in methane emission via enteric fermentation. Along with that, different physical processing such as chopping, grinding and steam treatment have been shown that it helps in reduction on methane emission. Physical process actually alter the structure and the composition of forage before it is attacked by the different microbial population. This process help in mitigating the enteric methane production by improving the forage digestibility, optimizing the fermentation and alter the microbial fermentation. Physical process mainly help in the breakdown of the plant cell wall and make the nutrient more easily available for the microbial fermentation. Some of the physical processing also help in the alteration microbial activity, like the steam rolling and pelleting, can modify the structure of the forage and finally alter the microbial population. This process can help in to shift the microbial population toward the more efficient production of volatile fatty acid like the propionate and butyrate, as we have discussed earlier. Along with that, other innovative practices like the silvipasture, means integrating the tree and shrubs in the pasture, can reduce the methane emission by improving the forage quality, reducing the methane producing microbes and sequestering the carbon. Along with that, different policy and market-based solutions are available with us to prevent the emission of the methane. Like that, we should encourage the farmer to adopt the methane reducing practices through the carbon credits or emission trading scheme adaptation that help into the lower methane emission. By providing the education to the farmers and the public about the benefit of reduction in methane emission and the different technology that they have that help in the reduction of methane emission. Along with that, different Indian government initiatives have been taken to reduce the methane emission. The government has supported the different research for the development and adaptation development of feed that reduce the methane emission. For example, certain feed additives, as we have discussed, tannin and the some of the essential fats can reduce the methane emission when they are included in the diet of ruminant. ICAR had developed one important anti-methanogenic feed, Harit Dhara, which can cut down cattle methane emission by 17 to 20% and also result in more milk production because that energy is finally used for the production of the milk. One important government scheme, that is the National Livestock Mission, mainly aim for improving the livestock production both qualitatively and quantitatively. Some component of this livestock mission, like the promoting the better health, feeding practices, and breeding technique, indirectly help in reduction in methane emission. One of the submission of the National Livestock Mission is the fodder and feed development. Under the National Livestock Mission, this submission aim in improving the availability of quality fodder to the animal. By proper feeding management, we ensure the healthier livestock that again indirectly help in the reduction of the methane emission. The Ministry of New and Renewable Energy encourages the building of biogas facility in the livestock farm. Biogas generation provide the renewable energy resources. Along with that, it also help in reduction in methane emission from the livestock waste. Another important government plan, that is a national program for bovine breeding and dairy development, that is mainly aimed to improve the milk production and improving the breed quality, again indirectly help in reduction in the methane emission. Along with that, Indian government have done many international collaboration, and India has been become the part of global effort that work for the reduction of methane emission through the various initiatives as the Global Methane Pledge. India is the participating in the international dialogue to adopt the best practices and the technology for methane reduction via the agriculture that included the livestock too. So here we can conclude that reducing the methane emission from the livestock waste is a multifaceted challenge, but there are effective strategies available to mitigate this emission. Key approach include the proper manure handling, adopting the anaerobic digestion for biogas production, improve the manure storage and application method, and incorporating different feed additives that help in the direction of increased methane production. However, the use of different additives to reduce the methane emission from the livestock waste is the most important area of research. Different feed additives like the alternative electron acceptor, ionophores, chemical inhibitor, and the probiotic have successfully shown that are very helpful in reduction in the methane emission, mainly via enteric fermentation. With the right combination of technology, management practices, and the policy support, methane emission from livestock waste can be significantly reduced that help in the combating with the climate change. Indian government initiative address the methane emission indirectly through the sustainable agriculture practices, livestock management, improved feeding practices, and conversion waste to energy program. Ongoing research and international collaboration also helping to introduce more effective measures to reduce the methane emission via livestock. However, improving the quality and digestibility of forage is the most important and most effective way to reduce the methane emission, mainly via enteric fermentation. By focusing on providing the animal better quality of feed and easily digestible feed, that will not only reduce the methane emission by the enteric fermentation, in result in overall improvement in the animal productivity. Thank you.